Alright, hello Falcons. I hope you're having a good spring break. I certainly am. I wish I could have gotten this video out to you a little bit earlier, but I had some technical difficulties. I'll talk to you guys about that once I get back to school and see you guys on Monday. But I want to go over at least one video with you. We are today going to learn about differential equations and separation of variables. So, do you guys remember in the first semester we did this thing called implicit differentiation? Basically, the principle about implicit differentiation was if I had something that was not a function, like, I don't know, a circle, okay, and I wanted to find a derivative at any x value, like let's say x value of 3. Well, do you see how at x equals 3 there are 2 points on that circle that have an x value of 3? So therefore, because that's the case, there's 2 tangent lines I could draw. So there's one tangent and then there's another tangent. And of course we could do lots of cool stuff with that we already have in the first semester. Here's the thing though, because I have 2 distinct points at x equals 3, when we took the derivative of this, we had to realize that I couldn't get it in terms of just one variable. It had to be in terms of 2. So it'd be like, 5x over y might be the derivative. So we've learned recently in the second semester that I can take the antiderivative to find what the original equation was. We're going to be doing the same thing now, but we haven't taken any antiderivatives when 2 variables have been involved. So that's what we're going to be working on in this video right here. They're going to tell us, hey, the derivative is, 5x over y squared. What was the original function? Alright, so that's what we're going to be working on. So hopefully that little picture makes it clear. So here's the first problem. It goes a little something like this. It says, if the derivative of y with respect to x is 4y over y, actually, slight mistake, 4x over y, and y of 0 equals 5, we want to find an equation for y in terms of x. Okay, so notice here's the main part of the problem. If I asked you in 7th or 8th grade, what is that? When it's one fraction equaling another fraction, hopefully you would have said proportion. And the way we solve proportions is to cross multiply. So we're going to do the same thing here. I'm just going to cross multiply. These 2 guys get cross multiplied. These 2 guys get cross multiplied. And if I do that, it's going to look like this. Y dy equals 4x dx. Alright, so we have y times the derivative of y equals 4x times the derivative of x. Okay. What we want to do here is we want to find the original equation. Right now, that's not what we have. So the way I get rid of the derivative is to take the antiderivative. Antiderivative just means, hey, let's put an integral out in front of this. So here's the integral, antiderivatives out in front. 4x dx, just like this. So didn't change too much there. It's 2 very basic antiderivative questions right here. If I have y dy and I want to take the antiderivative of that, well, I'm going to go y squared. Right now it's to the first, so I'm going to get y squared. I increase the exponent by 1, and now all I do is divide by that same exponent, 2. So we get y squared over 2. On the right side, well, right now again the exponent is 1. I increase it to 2. Once I increase it by 2, that's also the number I then divide by. So I think you agree it's 4x squared over 2. Now, that's not quite the exact answer. Remember, whenever we take the antiderivative, we need to add a constant value. So I'm going to add a constant value. For anyone wondering why I only added it on one side, it's because we only need one constant. If I put the constant over here and here, well, since we don't know what the constant is yet, we really only need one of them. We don't need 2. Then we can simplify this a little bit. If I get y squared over 2, you can divide by the 2 here, and we get 2x squared plus c. So there's the first simplification. Obviously here this is being divided by 2, so if I multiply both sides by 2, we're going to get y squared equals 4x squared plus c. Again, we don't need to multiply the c by 2 because we don't know what it is. So c is good enough. From here, well, we were given an original piece of information right here. Y of 0 equals 5. Now, I don't think we've seen anything quite like this in some of the problems we've done in the past. Usually it's f of 5 equals 7. Okay, we know what that means. If I plug 5 into the function, the y value is this. So in this case, when I have y of 0 equals 5, some people might say, ooh, the 0 is next to the y, so that's the y value. Not the case. This actually means when I plug in x is 0, I'm going to get a y value of 5. So when you see y of 0 equals 5, whatever value is in the brackets is, hey, if I plug that value in for x, the y value is going to be 5. So now I can use this to substitute into this equation to find the constant. So let's do that. Y squared, so that's going to be 5 squared, which is obviously 25, equals 4x squared. Well, x is 0. 0 squared is 0. 0 times 4 is still 0. So we get 0 plus c. So 25 equals 0 plus c. You can let your little brother or sister do that one because obviously 25 equals c. Now that I know that, we can plug that back in right here, and we get y squared equals 4x squared plus c, plus 25, because that's what we just found the c to be. Now notice in the question, we always want to answer what the question is asking, not what we think the question is asking. We always want to be very precise, and I know we've seen a lot of examples through the year of where we haven't quite answered the question exactly the way they've wanted it. Okay, and that is a big deal. We have to answer exactly the way they're phrasing it. Notice they said find an equation for y. For y in terms of x. This equation right here, yes, y is there, but it's y squared. We don't want that square, so we want to get rid of it. We all know how to get rid of a square, I hope by now. We just take the square root, so we're going to take the square root of this side, and I take the square root of this side. And when I do that, the square root of y squared is y. Then, I know it's really, really tempting, but we cannot go, the square root of 4x squared plus 25 is 2x plus 5. People are going to want to do that. We can't do that. If you're wondering why, let me just briefly explain it over here. Because here's the thing. If I took the square root of 2x plus 5 times 2x plus 5, this answer would in fact be 2x plus 5. Because notice I have 2x plus 5 written twice, and then we can simplify it. It is 2x plus 5. But in this case, can we turn 4x squared plus 25 into 2x plus 5 times 2x plus 5? Obviously that's not the case, because if I FOILed this out, is that going to be the same thing, or is it going to be something different? It's going to be something different, because we're going to actually get 2x times 2x is 4x squared, 2x times 5 is 10x, plus another 10x would be 20x, and then the 5 times 5 would be 25. So you see how 4x squared plus 20x plus 25 is not the same thing as 4x squared plus 25? That's why we just have to leave this as is. We're not going to simplify it. That's a common mistake people are going to be making. All right, and I know you did a really good job on that in Algebra 1 and Algebra 2, but it's something we need to rehash every so often. So hopefully we leave it as is, 4x squared plus 25, and that is our correct answer. Notice it's in terms of y, so we answered the question just the way they wanted us to. So there's the first question. All right, hope that's making sense. Keep in mind, they could make this question a little bit harder. They can add some trig to it. They can use substitution. They can do a whole bunch of different things to it. And we're going to take a look at that in the next videos. All right.